Okay, for this demo, since we're going to set on YouTube too, they let me not wear the mask. So I'm going to stay 6 feet away from you guys. Okay? This is one of my favorite demos to give. The bandsaw is such a neat tool. A bandsaw, how to tune it up to make sure it's really, really doing what it's supposed to be doing. We're talking about the accessories you can put on it to make it more accurate. We're going to talk about different things you can add to it. We're going to talk about the blades and all that good stuff. So, let us begin. The neat thing about the bandsaw, it gives us much more versatility in our shop. We can do things that we can't do with the track saw, that we can't do with the table saw. For example, I can do nothing with this block of wood with a chop saw or a table saw. It's just too thick. And if I want to save certain features of this, if I've got a beautiful piece of quilted, just gorgeous wood, and it's in a thick block, I could use the whole block for a little thing, or I can slice it into thin strips and make my own veneers, glue it to a substrate. And now I can really get my money's worth out of this beautiful piece of wood. So this allows us to do stuff. I'm going to pass this around because when you do resaw, you're going to get what this board did a lot, okay? And you're going to see that when I took the pressure off, it bowed, and on this side, you can see the tool marks. So if I'm going to glue this to a substrate, I don't care about the tool marks. However, I'm going to get a better glue bond if I sand this smoother. The smoother the wood is, the better the glue bond. Let's look at what we got. On this side of the bandsaw, we've got our blade, we've got our bearings, side bearings here, and these bearings are supposed to be just behind the gullet of the saw. The gullet on the blade is this big area right here. That's where all the sawdust goes into. So we want if you're using ball bearings or if you're using a cool block or anything like that, you want that to be just behind the gullet right here. The blade here, you can't see it very well, but there's a round bearing that's the wheels on the edge. That's called a thrust bearing. The thrust bearing touches the back of the blade. So when we push wood through, the blade isn't pushed back. The thrust bearing keeps the blade right where it is. And on these saws, there's a set above the deck and there's a set below the deck. Both sets have to be adjusted. The best thing to do when you put on a blade, you have both doors open. You have the saw unplugged. You're going to take these bearings, you're going to push them all as far as they'll go. You'll take the back one, push it back as far as it'll go on the top and the bottom. And then you're going to put the blade through here and through here. And you're going to turn this by hand. And you're going to try to put the blade where it's supposed to be on the tire. There is a big debate in woodworking about the blade is supposed to be on the tire. Some people like the blade tapped dead center, which means that here's my blade. It's coming over the tire this way. The center of the tire is right there in the center of the blade. Now, when we see that, we notice there's a lot of distance between the center of the blade and the teeth. Because of that distance, and the center of the tire is the highest point of the tire, everything else runs down from there. The greatest tension is on the center part of the blade. And what happens to the teeth? The teeth are not supported, so the teeth can flex. The teeth will flex. It's different for different thicknesses of saw blades. So you can't set up a fence at an angle that's going to be the same for all the different blades. It's different for each blade. And what you normally do is you create a wedge that is the degree of flex that your blade has picked. How do you determine it? All you do is you draw a line down the piece of wood and you put it in here away from any fence and just cut straight. You want the piece about 24 inches long. You want to cut about 12 inches into it, and you're going to be moving that wood to follow the line. When you get about halfway done, turn off the saw, stop, don't touch anything, and that piece of wood is going to be sitting at an angle. It could be sitting like this. It could be sitting like this. It could be a great angle. It could be a little tiny angle, but it's going to be sitting at an angle. That's the angle of deflection. That's what you have to make on the fence so you can just push this through and it cuts perfectly. Without that, you're going to have to draw a line that you want to cut, and they make a round circular piece of tube steel that can go on a bandsaw fence. It's a pivot point. It's right here where the teeth are, and all you do is back and forth to stay on that line. Okay? The other school of thought on where to put the bandsaw blade is if we put the gullet here, right on the center line of the tire, so that the greatest stress is holding those teeth dead straight. Most people don't like that because on a 3/4 inch blade, you got about 1/8 of an inch hanging off the tire. Don't care. It's not going to affect the cut or anything else like that. This saw is set up in that method. What that will do is that takes the deflection out of the tooth. Now, with the straight fence, you're going to be slamming stuff all the time, and it's going to do a very, very good job. So we kind of want the center of the tire and that gullet to be really, really close. Now, you're going to find out that that really only matters on big blades like this. This is a 3/4 inch blade. This is a 1/2 inch blade. And now you can see that the gullet is much closer to the center of the blade. We go to a 1/4 inch blade, and there's really no difference. Okay? So, well, if you, the neat part of that, if you still line it up on the gullet, the only thing that doesn't change is the end of the gullet. So, if I set the machine up for this, and then took it off and put this on, and then took it off and put this on, and I lined it up on the gullet, then for all three of these blades, I don't change these front bearings at all, either top or the bottom, because the same part of the blade is going through the bearings, right where the gullet is. I will have to change the thrust bearing, but it's much easier to adjust 2 thrust bearings than 6 bearings total. And depending on the manufacturer, sometimes it's easy to get under the deck, sometimes it's very difficult. I've got an older Rikon that, for all practical purposes, I just take the deck off, do all my adjustments, put it back on because it's faster, rather than trying to, get all nudged around. So, what we want is we want to put the band blade on where it's going to do the most good. And I really think that's with the back of the gullet. Most people think that these have to be coplanar. Please do not do that. This has been set up from the manufacturers to do exactly what it's supposed to do. Everything is geared. All the measurements were from, that's where all the standards are set from. You'll find out that most of the time, where the blade is on the top tire is not where the blade is on the bottom tire. If you look at the bottom tire, you'll find out that that blade is sitting more towards the middle. So if the blade is sitting more towards the middle down here, that means technically this blade is coming through here at a little angle like that. That's okay. What we're concerned about is the 90 degree this way and this way. We're really not so much concerned about that one, because these are all the through cuts. So please don't try to make these tires coplanar. Just, this is what you want to have all your attention on. So When you're going to change blades too, it's a good time to go through the whole machine and vacuum up all the dust and debris. You want to check the bearings anytime you change a blade to make sure they all turn freely. And what they're supposed to do, top and the bottom. When you're doing that, this is a great time to add any bearing lubricant that you need. So we can take some of this and we can spray it on those ball bearings, and we'll be good to go. Top and the bottom. Don't really worry about these so much. These are kind of sealed, but this is the stuff that we can actually work on. If your deck is got some rust on it, you put some wood on there that was wet, you didn't move it fast enough and rust is developing, what you want to do is you want to take something like this, rust-free, spray it on there, scrub it down with a pad. I like to use these gray or green non-woven pads. I used to have some in here. Here's a gray one, like this. And just spray this on, let it sit for a little bit, rub it down really good, wipe it off really, really good, because this will turn the steel colors. It won't hurt the steel, it'll just change the color if you leave it on there too long. And then do is put a lubricant on here. You can use paste wax, you can use stuff like this that you just spray on, and it makes this very slippery, makes it easy to get the wood through. Plus, all of these products are designed not to be absorbed by the wood, not to affect the finish, not to do a color change. This is really just for the wood. If you're going to do some really thick stock, like some resawing, they make the saw blade lubricant, and all you do with this one is just turn the saw on, touch the side, run a piece of scrap through, and now you're ready to go. This will keep the saw blade going through the wood easily. It won't generate a lot of heat. It's just a good thing to have. So these are kind of stuff you want to have in your back pocket when you're doing getting this ready for the cutting year. Most saws now have a detensioning lever. It's in the back. If you leave the saw fully tensioned, does it hurt the saw? Doesn't hurt the saw at all. What it does is it puts a cup in the top tire. And over time, that cup's going to get more and more pronounced. Well, how does that affect the blade that's on there? It really doesn't. However, if I try to put a little blade like this on, and it fits into that, and this is not going to get a good grab, the tire's not going to grab it well. So we really want to take the tension off. And for most of these things, it's a lever you pull down. Sometimes it's a lever you pull up. And get used to the fact that when you detension, you can't look at this from the front and really see if it's detension or not. Get used to when you walk up to a bandsaw, do this. The blade moves like that, it's detention. When you drop it in here, that's what you want. As far as everything else goes, clean it up inside. You want to be cognizant of the dust collection. This is a bigger bandsaw. And in this bandsaw, we've got two 4-inch ports. We've got one down here at the bottom and one here at the top. So this one, to actually do proper dust collection, it's got to be hooked up to two 4-inch hoses. You can wire them and take them to a 4-inch dust collector. But this is affecting a lot of this dust, sawdust, it's going to be floating in the air. And there's really no good way to capture it. So it's going to try to get most of it here, but the stuff it misses is going to filter down to the bottom of the cabinet, and that's what the one at the bottom is going to get. So between the two, it does a very good job of trying to get that in place. You always want to make sure that all the guards to protect you are in place and ready to go. When it comes time to cut, when you cut, most people would cut this like this. What you're supposed to do in a bandsaw, you loosen this, and you want to drop this down so this is almost touching. Lock it in place, because if I break the hand, move, on both sides. After that's a piece of cake. Turn it on. Plug it in. Plugged in? No, not plugged in. That's why I leave these out. Now, for safety, there's two types of on and off switches you'll find in tools. One's a magnetic switch, one's a non-magnetic. A magnetic switch is what you really find in table saws and things like that. That means if your saw is on and the power goes out, you can walk away from the saw because when the power comes back on, the saw won't start. Some have non-magnetics like this, which means if there's a power failure and you walk away from it, say it's 5 o'clock in the afternoon, you're in your wood shop and the power doesn't come on until 3 o'clock in the morning. At 3 o'clock in the morning, your saw is going to start. Just like this. So, when it goes, now technically it should be off. It shouldn't start when I plug it back in. It's one of the things you have to know about your tools. Okay? There's nothing inherently wrong with it, but you just need to know that if the power goes out, another thing you don't want to do is you don't want to walk away from anything like this when it's going. So always make sure that you hit that switch. What we're listening for is any obvious noises of stuff rubbing together that's not supposed to. Everything's winding down like it's supposed to. This saw doesn't have a brake on it. Some bandsaws have a brake, so as they start to throw down, they'll really stop quick. So those are features you can look for in different types of bandsaw. 14 inches has got some bells and whistles. It doesn't have all of them, but it's a good standard bandsaw. No, you're going to get whatever the manufacturer put in, that's what you got. You don't change your RPM. Unless it's a metalworking and woodworking bandsaw, then you'll have two speeds. But it's either one or the other. Most of the time, you just leave it on woodworking. The cutting is unique. You wouldn't think it'd be hard. But most people don't understand how a bandsaw works, how the blade works. And basically, everything you're doing, everything you're pushing to the saw, when you get teeth, you're pushing straight in. Now you'll see me do a circle cut in a second. When I do this cut, I'm always pushing straight in on the blade. I'm not pushing from the sides or pushing this way. And that's one of the biggest boo-boos I see is you have to plane your cut. The easiest way to plane your cut is make a line and just follow the line. And once you have to follow a line, it's easy to twist this so this is always going in there. I'm not pushing this. I'm just rotating this around and bringing that line right into those teeth. You can tell you're doing it right if you look at the sides and there's no burn marks, okay? If I'm doing it wrong, this is going to cry. Yeah, I didn't do too bad. But you can see some of the dark marks already. And that's because way too much the side, and you're gonna not only get the friction from rubbing the side of the blade because these teeth are set out. Theoretically, if you do this right, you really never touch the blade itself. You just touch the teeth. this is always going through the groove. So the biggest thing I can say on cutting on the bandsaw is just take your time. It's a type of saw, though, that if you're cutting especially if it's curve cutting, do not back out. Turn the saw off. When it comes to a complete stop, then bring it out. Okay? If you bring it out while it's running, you're going to pull the blade out of the bearings. And then, now it's much easier. If we tried it when it was running, that blade, it'd be right there with us. So we just want to take our time. It's a very easy machine to do. And we've got some neat stuff that we can do with the machine. First of all, these machines come with a fence. A fence is something that we need to look at also. This has got a very nice fence. It fits right in here, slides over. We've got a magnifying glass here. We've got a ruler so we can tell where we are in the scheme of things. And we've got this fence. This fence goes on two ways. It goes on this way, so we can have small stock close to the blade. And we also goes on this way. Now here we can't get small stock close to the blade because the fence hits here. But this is what we'd use for resawing. So a bandsaw fence should give you both options. It should give you one for small stuff, and it should give you one for big stuff. Okay? Now, let's do big stuff for a second. So this is a resaw fence. A resaw fence is what we're going to use to take wood like this and slab it down. Say this has got a really pretty cut that we want. And we know that this blade is going to track true. Now, if we're resawing stock like this, we pretty much have to measure what we want for distance because we can't get closer than that. So if we want to cut something like this, saw-wise, this is the smallest piece I can cut before this fence hits this. So it leaves me with two options. Either I can, excuse me, put a secondary fence here that this, or I can flip this down and use this to track this for the. Now, this is going to be as stable as it can, but it will work. The other thing you can do is move this away entirely, draw a line right here, set this down, and just follow the line. And you can get a fairly good cut like that. If you are doing a wider piece of wood, though, now I can resaw like crazy. Bring this right up here. Because normally, like I said, you try to get this near the top, but in this case, this is as low as we can go, and that's fine for this. Okay, we can resaw now the different thicknesses. Normally, to resaw like that, we tape measure a ruler, and we're trying teeth. When these teeth are spread out like that, they're not the center of the blade. They're just where the cut's going to start. Want a precision thickness, it's going to be hard to do that really, so you're always going to cheat on the thicker side. But there are different things that you can get for your saw, and this is one of them. These are called, I like these, the Fence Alignment System Tool. They call it FAST. And they're these blocks and they're different thicknesses. This is 1/2 inch. So suppose I wanted to, well, let's go 1/2 inch. Let's go to 3/8 of an inch. This is 3/8 of an inch. So if I do this right, then I can cut off 3/8 of an inch strips. How does it work? There's a ruler here. I know that's 3/8 inch thick, but there's this magnet and then there's this groove, okay? Clues. The groove is where the saw teeth go. So this is going to come on this side. The saw teeth are going to go in the groove. That means it is holding this flush. Now I can bring this over. Touch those. Lock this in place. And I'm set for 3/8 cuts. For smaller blades, you wouldn't be cutting thick like that. You'd be doing, here's for 1/8 inch cuts. When I'm making my own veneers, I'm doing, my favorite cut is actually 3/16, which is a 16th over an 1/8. So actually I'm putting this one and this one. So if I'm going to err, I'm always going to make it a little thicker and take a little bit more off on the planer, but it's, that way I know I'm not too thin is deadly. So let's see if this works. Now most people do this, and that's okay up to a point, but there's going to be a point in there awful close to this blade. This is one of the best tools that you can get. This goes right here, got a big flat area. This pops out to catch it. I love this tool. My hand is nowhere near that. This is why putting that blade where I put it, look at that. That is absolutely perfect. So when you put that blade on that tire like we did, you can start slabbing stuff like crazy, just like that. Your cut's always between this and the fence. I can put this back. I can just keep on going and going and going and going and get a whole bunch of slabs just like that. That's the versatility this tool gives you. It takes a little extra time to get the blade set just right, but once you do, you can roll through stuff like that like crazy. If I want to change the thicknesses, I can go to this fast system, make it really simple, or I can take a little ruler and try to look down there and see. I'm a big believer in this. This really works well. When you pay for accurate measurements, it only hurts the day you pay for it, and after that it pays for itself. This is the common resaw blade. That's a 1/2 inch blade there. This is a common resaw blade, 3/4 of an inch. I'm going to stand over here so I'm 6 feet away from everybody, so you can see. So it's a nice thickness. Well, the thicker the blades are this way, the more they don't want to bend. So this actually puts a lot of strain on a 14-inch bandsaw because it's got to wrap around here really tight. And it does a very good job at what it's supposed to do. You want about 2 to 3 teeth per inch on a resaw, okay? And this is 3 teeth per inch right here. Big gullet, big teeth, does a great job. However, I would submit to you that I can get just as good resaw from a 1/2 inch blade. 1/2 inch blade doesn't put the strain on the saw and the tires like the 3/4 inch does. I can get it with 3 teeth per inch. I can get it with 6 teeth per inch like this one. This is my favorite. 6 teeth per inch is a great compromise. So this one is also 6. 1, 2, 3, 4, yeah, 6 teeth per inch. And it's a great compromise. It's a good general purpose saw. It will do nice curve cuts. It will do resaws very, very well. The thicker the piece is, the taller the piece is, the more you're going to stress a blade like this, the more this is appropriate. But most of the resaws, very rarely do I redo a resaw the whole 12 inches of this. At most, I'm 8 to 10 inches. If I've got a piece of log that's 8 to 10 inches thick, that's a heavy log. And I've got a cradle that goes in, and I start cutting it. And as soon as I start cutting it, I have it, and then I put it in another cradle, and I can start slabbing it. So really, when it comes to what you're going to be using more often than not, you can do almost 95% of all your sawing on a 1/2 inch blade, 1/16 per inch. 1/16 is not as aggressive, which means that you don't push it through as fast, but it also means the cut's smoother. You don't have to sander as much like you do a 2 or 3 tooth. If there's a general rule of thumb about bandsaw blades, it's normally that you really don't want more than 6 teeth in the wood at the same time. So if this is 6 teeth per inch, it's telling you about 1 inch thick is what this saw is really, really good at. Can you flip the wood on the end and saw it long? Oh, I just did it. Works great. But for normal, when you're deciding what blade to put on your bandsaw, and you think about what you're going to be doing mostly, if you're going to be working with a really thick stock, you need to be kind of drifting towards just 3/4 inch. If you're going to be working normally 3/4 or less, or a little bit bigger once in a while, 1/2 inch will do everything you want. If you do really small model making stuff or really scrolly stuff, 1/4 inch to 1/8 of an inch. What I don't like about these blades is that they're so thin widthwise that if I've got a ball bearing here holding it in place, the thrust bearing can't get to the back of the blade. So you have to have a different type of arrangement with your bearings. You don't have that with a 1/2 inch. So 3/8 is really the smallest I think you should go to on one of these, and then everything is 3/8 or 1/2 inch or 3/4. Personally, this is my favoriteest blade in the whole wide world. 1/2 inch, 1/16 per inch. Really not a whole lot you can't do. If you need to saw lumber so thick and slab it that you're pushing the size this way, you talk about a whole different saw. Now, if you go to any sawmills in the world nowadays, except the ones that were back for the turn of 2 centuries ago, they don't have those giant blades anymore. They have big bandsaws. Bandsaw blades that are this wide. And those machines just saw the wood like nobody's business. So bandsaws really, really do a good job. For us, the average woodworker, this is really all that we really need. Now, when you talk about blades too, there's different types of blades. This is a straight blade, which means it's good steel, it's flexible. Usually when they harden this, they harden 2 things. They harden the teeth and they harden the back. And they try to keep the middle flexible. But it takes a certain amount of tension on this blade to hold it nice and taut so that it's giving you a good cut. And normally the tension indicator is here someplace. There's a little lever that's going up and it should be pointing to a 1/2 inch. And these are Timberable plates. These are my favorite blades. All my blades in my shop are Timberable. This is silicone steel right here. It's hardened on the teeth, it's hardened on the back, and you can see where they hardened it. This is extremely flexible. What I like about this steel is it doesn't have to be tensioned as hard as regular steel. So while this might be in there tensioned for a 1/2 inch, this could be in there also tensioned for a 1/2 inch. It takes the pressure off that top wheel. So I really am a fan of silicone steel. It's much easier to use. Now, with any of these blades, you can do 2 things. You can go by what the indicator says, and that's a good manufacturer put it there for. And they make it as accurate as they can. If for some reason you don't see that, or using a silicone steel that has a different temperature, tension, what you do is called the Flutter Test. And we really can't do this here, but basically when we put the blade on and we got it sit on the tire, all these bearings are still away. We haven't adjusted anything else. All we've done is put the blade on, and we've started to tension it. What we want to do is, when it's on there nice and good, we're actually going to turn the saw on. And this blade is going to be like this in there. And this is all the way up, and it's just one like this. Back in the back, all the bandsaws are a little different. Some of them are, you tension on the top. Some of you tension behind. This one you do it on top. You start turning the tension lead. And that flutter is going to get less, and it's going to get less, and finally you're going to do a turn, bam, it's straight as a string, okay? Once you get that point, turn this another quarter, and you're done. Regardless of what this says, for this blade and this bandsaw, it's the proper tension, okay? So if you don't have an indicator, or if you're using a Timberwolf, which is going to tension at a lower point, then you do the flutter. And it's really easy to do. You just want to put enough tension on the blade when you first start off that it's not going to run right off the tires. So you put a little tension on it, like take it up to 1/8 of an inch or something. Start from there. Just technique, that's all it is, but it does a very, very good job. You should be good to go. Makes like you. Yeah, you have this as high as you can get it. Yeah, you don't want anything touching that blade. You just want the blade itself to be going, and it does a very, very good job. And you saw how nice, that piece of wood was, if you look at it, it's the same thickness all the way through, and that's exactly what you want. If you have stuff like this, you can be really exact on your thicknesses. It's really great when you're doing a really pretty veneer. Like every is the tool mark, so this gives me something to sand. So you always know that even though when you start slicing, you're not done with this because they need to be sanded. You can see how a 1/2 inch, we can do all kinds of wavy lines. We can do nice little curves. Another thing you need to look at when you look at how this is set up, you need to make sure that your deck is square to the sides of the blade, okay? Don't say this needs to be level. This needs to be square to the sides of this blade, because these things sit on different types of mounts. So I can take this thing that's worth its weight in gold, and this is a digital angle gauge. I can turn this on. It's saying this is dead flat, okay? I can take it over here and put it on, and it says this is off 0.02. So flat is relative. To me, this tabletop is dead flat. To me, this is dead flat. I can't tell the difference. But if you're doing precision cuts, you need to be able to tell the difference. So what we want to do is if this is square to the blade, and we're going to take it right up here and touch it, and we shouldn't see any gaps. And this is square to the blade. You're never going to be square this way because the tires are going to move that blade. Normally the blade is a little closer on the bottom than it is at the top. Not, but we don't care about square here because it doesn't matter. All our cuts are through cuts. We care about square here and here. And if this is square, it's square on the other side. So why is that important? Well, if I'm making an Adirondack chair, and I've got to cut a piece of wood at 4 degrees or 30 degrees to get everything in this deck. And normally, this is to show you, normally you take this off, but we'll flip this, we'll raise it up, say that's where we want to cut, we'll lock this in place, and now we can cut at this angle. This is the important thing because this is square to that. So I am going to cut a precise angle because of that. Okay? So don't think of this deck as being level, because I'd be shocked if it was. Our floors aren't level. The bases aren't level. We just do the best we can with what we got, but we can make sure that this angle is precise by making sure that this at 0 is square to that. All measurements come from that. You also see that most of these things have this here. That's adjustable. That's your return to square. Okay? So you are going to move that around when you put this up, and after a year of sitting in the shop, you're going to do your yearly tune-up. You're going to make sure that's still accurate. And then when you drop it down and lock it in place, it says 0. So we can always return to our 0 point. And I highly recommend, if you're going to use this, is great, because you do what you got to do. You can also use it for table saws. You can put on the blade. Then you know for exactly, if that blade's set at 90, you're square. You pop this on here and you can turn it. You want a 30-degree cut, you're going to get a 30-degree cut with it. I wouldn't trust the scale on the saw. This will give you precise. So these are tools that you should have to work with your equipment to make them better. And also, when you do your yearly tune-up, you also want to look at things, what needs to be replaced. The things we replace most on bandsaws are these two items: the tire and the bearings. Okay? Tires are easy. These are generic. 14-inch wheel is a 14-inch wheel. Get a 14-inch tire, you're golden. These are, every manufacturer's different sizes, different that. But check the bearings. Normally, what I do with my Rikon, every year I check the bearings. Every year I replace a couple. Every other year I order a sleeve of 10 bearings from Rikon, and I just have them in my shop. So when I check them, and they're easy to replace. The screws here are normally M3s. They're metric. But you can go to Lowe's or Home Depot, go to their metric shop, and you can see M3s all day long, so you can replace those screws as you need them. There's nothing special. Just have to look, unless you want to replace them with bearings. And those are kits. Carter makes a kit that does that. Now, those kits are like $150, but I think they're much worth it. They're very much worth it.
So is it without vacuuming? Is it worth switching your stock to the Carter?
I did on my Jet, and that was like getting a brand new bandsaw. Now, I've since sold that, and I've got the big Rikon, and it's got the double bearings, and I love that. It's a great saw. Oh yeah, they're not, yeah. So really, for the person that has a bandsaw in a shop that does weekend woodworking and may use it 3 or 4 times a year, they're fine. If you're going to do some serious work, you need precision in your cuts, and these are going to give you that. If you look at these two bearings right here, these are double bearings. They're this big. So I've got actually 2 of these on this, with the second one off the edge just a little bit. Okay? They're more stable for thicker blades. You will note, you can't see this, but these bearings are actually smaller than the bearings underneath. The bearings underneath, they try to make these more foolproof because it's hard to get to. So these are underneath is a little bit more robust. These are the ones that you do all your adjustments on. Most people forget to do the bottom. To tell you the truth, when I got this saw out to use it for the demo, they changed the blades on there, and the bottom thrust bearing was this far away from the blade, which means that if you push down here, that whole blade's going to go in here, and it's going to take the teeth and run the teeth through the bearings. It's going to squeeze the teeth together. It's going to really hurt these. It's really going to hurt the blade, and doesn't give you a good cut. So you really want to make sure that you check top and bottom, because sometimes if you don't see it, over years the vibrations might be moving stuff. So always make sure that you do your yearly checkups. You look at the tires, you check all the bearings, and make sure everything rotates freely, everything is clean. If you need to take rust off or lubricate anything, you're good to go. Make sure you have the proper tools and wrenches to get to everything. This, I can't say enough about Timberwolves. I really like the silicone steel. Now, that being said, do I have any problem using like a Starrett or something? Oh, absolutely not. These are great. Starrett makes more bandsaw blades than everybody else in the world combined. And they only make it for woodworkers. They make them for metal workers. They make them for butcher shops. They make them because different bandsaws do different things. The concept of a bandsaw is really, really good. It's a good saw. It does most anything. Whether it's slabbing stuff, whether it's going through really thick stuff, it's just good. And you can have this do repeatable cuts. The jigs you make for your table saw, you can make for a bandsaw. You can put a jig here and go straight through, and you can put stuff here and just chop it all day long. This is a great saw. Granted, the table saw with its stiff blade is going to be easier to get really precise cuts, but it's not difficult. Okay, it's a little bit more difficult, but it's not impossible. So it's a really good saw. This is one of the saws I use. I probably use this more than I use my table saw. I like making humidors, and I'm slabbing stuff all the time, especially Spanish cedar. I'll buy thick Spanish cedar and just start cutting off in 3/8" chunks and go from there. Most all the stuff I do is dry, kiln drying, because the kiln drying takes a lot of the stresses out. If you're slabbing wet wood, there's nothing wrong with it besides rusting your saw, but you're going to get a lot of movement. When you come back after 6 or however, it's going to make much thinner job, but you're going to get movement out there crazy. So if I'm cutting wet, I'm slabbing it at least 1/2 inch thick, because that gives me a lot of movement. And this was kiln drying. This moved a little. When you take the stress off the wood, wood's going to move. But you can make cuts like this that you just can't make with any other saw. So you can take some beautiful stock like that, and you can start slabbing this. I can drill a hole right in here, put a hook on it, put a little clock in there, and I can sell that for $50 at a yard sale. These bearings shouldn't touch the blade, which means that if I turn this saw on, none of these things should move. Now, sometimes that's kind of impossible. And the reason I say that is because you might get a little pitch or gum on the bearing so that when it moves, it's going to be enough to touch it. So many years, I haven't noticed any problems with them touching, but theoretically, they're not supposed to. How this works with these newer ones is you take these, loosen this, loosens the tension. Then when you can take your wrench, or you can just grab these. I'll show you this one here. I can loosen that, and I can turn this, and this turns away from the blade. Now, if I was going to set this up, I'd take a dollar bill, just stick a dollar bill in there between that, move this till it touches the dollar bill, and then lock it in place. To lock it in place, I just tighten this right up in here. But that way, it will not touch. But as soon as the wood hits this, blade's going to do two things. It's going to flex, and it's going to go back. The thrust bearing is going to hold it in place. That's why we want these things as close to the gullet as we can, because that way it's not going to let those teeth. So we've got good tension up here. We've got good tension here. We've got back here that doesn't let the blade go any distance backwards, because then the bearings are going to get into the teeth, and that's going to be a bad thing. So the nice part about this is once this is set up, I'm done. I'm done for a long time. That's good. That's a good blade, and these things last a good long time. On the hardness and the density of the wood, and if you're doing a lot of resawing, you're going to wear it up faster. Also, if you're going to resaw, you're planning to do most of your work as resawing. I would submit to you, you do not want a 14-inch bandsaw. You want an 18-inch bandsaw or above. If you want a good general purpose, you can do anything you want to in your shop. A 14-inch is fine. It will do good resawing. It's not a production resaw. So you can resaw for you've got some beautiful figured wood, and make your own veneers to put on drawer fronts, because it's going to look stunning. There's your bandsaw. If you're coming to work Monday through Friday and all you're doing is trying to slab 1,000 feet a day, this is not your bandsaw. Okay? So be governed accordingly. This is meant for the This is really cutting edge for the average woodworker. For a lot of them like to make projects, sell stuff, things like that. This is a great. What you're looking for in a bandsaw like this is at least 14 inches. You're looking for good clearance here. You're looking for a motor that is at least 1 3/4 horse or above. Bandsaw is actually a horsepower bandsaw because I take big chunks of lumber, of logs, I cut about each thing, and I stick them end grain up, and I just go through the bandsaw to cut them in half, and then flip them over. I cut bowl blanks. And my bandsaw hadn't worked hard. 3 horsepower eats it. So knowing that if you're going to have big chunks of wood, you're going to need some reach and you're going to need some power. But for the average, this is perfect. At least don't buy it if it's not, if it's a horse and a half, you're really starting to underpower. You want 1 3/4 or at least 2 and above. Now, when you go to 2 and above, you're at 210 volts. That's okay. Any questions?